Assalamualaikum and good day everyone. So today we are going to proceed our next lesson, still on non-homogeneous equation, but on how to find YP by using another method, which is variation of parameter. Okay, so the general solution is still the same, which is y equals to YH plus YP, but before this we find YP by using UC. So now we are going to get YP here by using another method, which is variation of parameter. Okay, so basically VOP, variations of parameter, is an alternative method to find YP if your fx has the form of the following function. Okay, so as you can see here, your fx is given here is not polynomial or exponential or trigonometric function with cosine sine. Okay, so it's either tangent, cotangent, secant, cosecant, 1 over x power n, and also ln x. Okay, so since we don't discuss this one in UC cannot solve this kind of problem. So if you have the function on your right hand side, which is one of these function, so you have to use variation of parameter. Okay, other than that, variation of parameter can also solve for problem where you have your fx on your right hand side is a polynomial, exponential, and also trigonometric function. Okay, so simply said, variation of parameter can be used to solve any kind of problem for fx. Okay, but you see based on case. Okay, that's like the case 1, case 2, or case 3. Okay, so for variation of parameter, if you have your fx in terms of polynomial, you still can use VOP. Or fx is in exponential form or trigonometric function, or also multiplication of that two cases. Okay, so basically we can use variation of parameter to solve any kind of problem. Okay, any kind of fx that you have. Okay, so how this VOP works. So the general solution is still the same, y equals to YH plus YP, but on how to get your YP here is this one, by using uy1 plus vy2, where u is given as this one and v is this one. You have to integrate, and y1 and y2 is based on your homogeneous solution. Okay, so these are the steps. So you may take a look at your notes in the module for these notes. Okay, so let's try to solve the first example here. So we have 4 examples, so I will try to discuss these 4 examples in 4 different videos to make it the video short. Okay, so the first one, find the general solution for y double prime plus 6y prime plus 8y equals to exponent negative 2x. Okay, so as you can see here, function on your right hand side here is an exponential function. Okay, so basically you can use either method of undetermined coefficient or variation of parameter to solve this kind of problem. Okay, because this is general question. Okay, but if the questions already focused, like you have to solve by using UC or VOP, then you have to use that method. Okay, so since we are discuss VOP, so I will solve this one by using VOP, variation of parameter. Okay, and we'll see you will have the same answer if you solve it by using UC, method of undetermined coefficient. Okay, so let's proceed. So now you have, okay, I copy back the question, y double prime plus 6y prime plus 8y is equals to exponent negative 2x. Okay, so let's refer to these steps to guide you to solve this one. Okay, so first you have to find your YH, still homogeneous solution YH. Okay, find YH by assuming fx is equals to 0. Remember, when you want to find a YH, you have to assume that your fx is equals to 0. Okay, so you will have y double prime plus 6y prime plus 8y is equals to 0. So change this one into characteristic equation will give you m squared plus 6m plus 8 is equals to 0. So you will have your m is equals to negative 2 and your m2 is equals to negative 4. Okay, so this is case 1. Okay, where you have different root. Okay, so therefore your general solution for YH is equals to AE negative 2x plus BE negative 4x. Okay, as you can see here, in step 1, you have to find your YH and write the solution in the form of AY1 plus BY2. So, this is your YH. So, what is your AY1? So, you were asked to write in the form of AY1 plus BY2. So, you know that your Y1 is equals to exponent negative 2x and your y2 is equals to exponent negative 4x. Okay, so this is your YH. Okay, this is your YH. Okay, we rewrite as this form because we want to get the function for y1 and y2. Okay, only for the purpose of getting function of y1 and y2. Okay, so if let's say you choose m1 as negative 4, m2 is equals to negative 2. Therefore, your y1 is equals to exponent negative 4x. Your y2 is equals to exponent negative 2x. Your y1 and y2 based on your YH. And your YH here based on your what you define your m1 and m2. Okay, you have to stick to this m1 and m2 until the end of the steps. Okay, if you choose this one as your m1 and m2, then you have to use this m1 and m2 until the end. Okay, don't worry, you might have a different answer in between here, but the last answer will be the same. If you want to compare your answer with your friend, you have to make sure that your friend also choose the same m as you. Okay, so next you were asked to calculate Roscian W. So the W, this one step 2. Okay, so this is step 1. So step 2, calculate W. So W is given by this one, y1, y2, y prime 1, y prime 2. So that's why in the first step, you were asked to define what is your y1 and y2 because you are going to use that function in the next step. Okay, so your y1 is equals to exponent negative 2x. Your y2 is equals to exponent negative 4x. So differentiate your y1 will give you negative 2 exponent negative 2x, and differentiate y2 will give you negative 4 exponent negative 4x. So therefore, your W is equals to y1, y2, y prime 1, y prime 2. Okay, this one. So substitute the function that you already calculate here. So you will have your W is equals to exponent negative 2x, exponent negative 4x. negative 2 exponent negative 2x, negative 4 exponent negative 4x. Okay, so this is determinant, right? So y1 multiplied by y prime 2 minus y2 multiplied by y prime 1. I already write it as here. Okay, so you will have this one multiplied by this one. So negative 4 exponent negative 2x times exponent negative 4x minus this one multiplied by this one. So you will have negative 2 exponent negative 2x times exponent negative 4x. Okay, so exponent times exponent, so power you plus, isn't it? So you will have negative 4 exponent negative 6x minus minus plus 2 exponent, so negative, so this is multiply, so power, we add the power, so you will have negative 6x. Okay, so therefore this one is equals to negative 4 plus 2, negative 2 exponent negative 6x. You get it? So for this one, let's revise as for this one. If you have EA dot EB, so this one is equals to EA plus B. If you have EA over EB, this one is equals to EA minus B. Okay. So this is your W. So next, you have to get your you have to calculate your V and W. But as you can see here, you already have your Y2, your W, or your Y1 and W, but you don't know what is your Fx and what is your E. So define your E and your Fx based on your differential equations given to you. Okay, so now the differential equations given to you is y double prime plus 6y prime plus 8y is equals to exponent negative 2x. So that you know your A is equals to 1, the coefficient of y double prime. And your fx is equals to exponent negative 2x. Okay? So since you already have your E, your Fx, and your W that you already calculate in the previous step, and your Y1 and your Y2 based on your YH, so now you can proceed with finding your U and V. Okay, why we need to find this U and V? Because your YP is given by UY1 plus VY2. So that's why you need to get what is your U and what is your V. Okay, your Y1 and Y2 you already have it in step 1. Okay, this is your Y1 and this is your Y2. So our problem now is getting U and V. Okay, so all the process to get W, A and Fx here is for you to get your U and V. Okay, so step 4, your U is equals to negative y over 2 Fx over AW dx. Okay, so just ignore the plus C and plus D first. Okay, I will explain to you later. Okay, so this one, this is your U. So what is your Y2? Your Y2 is equals to, so negative, so Y2 is equals to exponent negative 4x. Your Fx is equals to exponent negative 2x. Okay, your a is equals to 1 and your w is equals to what you calculate in the previous step, which is negative 2 exponent negative 6x. Negative 2 exponent negative 6x dx. Okay, how are you going to integrate this function? First, factorize the constant. So as you can see here, you have a constant negative 1 over 2, isn't it? So factorize this one. So negative negative will be positive. So you will have 1 over 2. Okay, so integrate. So simplify the function, the numerator first. Okay, so when you have exponent by times by exponent, so we add the power. So you will have exponent negative 6x. Okay, and for the denominator, you also have exponent negative 6x. So simplify this one dx. So simplify this one will give you 1. Okay, not 0, this is 1. Okay, so you have to integrate 1 with respect to the x. So therefore you will have 1 over 2x. Okay, as you can see here, actually when we integrate with no limit, you have to add plus c, and another one is plus d or plus another c, isn't it? So but for this case, we don't add such plus c and plus d because we want to make it short for you to calculate your YP. Okay, so that's why we don't add plus c here. Okay, or plus d or plus any constant here. Okay, basically you should have the plus c. Okay, but for this purpose of VOP, since the step is still long to go, so just ignore the constant part here. Okay, so next you have to calculate your V. So your V is given by, so there's no negative here, and this is y1. Okay, other than that remain the same as the how you find your u. Okay, so your V is equals to y1 fx over aw dx. Okay, so what is your y1? So your y1 is equals to exponent negative 2x. Your fx is equals to same thing here, exponent negative 2x. Your a is equals to 1. Your w is equals to exponent, sorry, negative 2 exponent negative 6x dx. Okay, so again here factorize the constant. So you will have negative 1 over 2. So integrate, so simplify the function, the numerator first, then you will have exponent. So negative 2 will give you negative 4x over exponent negative 6x dx. Okay, so how to simplify this one before you can integrate? So remember I told you when you have a division of the exponential, so you will have exponent a minus b. Okay, so in this case you will have negative 1 over 2. So integrate, so exponent negative 4x minus, so what is your b? Negative 6x. Okay, dx. Okay, or another way of doing it is you just bring this one here, you just bring the exponent negative 6x to the numerator, so you will have exponent 6x, so you will have the same thing. Okay, or just use this one. Okay, so as you can see here, a minus b, why this is b? Because this one is b. If you have negative b here, then you will have a minus negative b. Okay, so same goes for this one. Since your a is equals to, so let us define. Okay, your a is equals to negative 4 and your b is equals to negative 6x. So a minus b will give you this one. Okay, So simplify this one, you will have negative 1 over 2, so integrate exponent, so negative negative plus, so 6 minus 4 is equals to 2x dx. Okay, so this is a single function, so you don't need any technique of integration. So therefore you will have, so integrate exponent will give you exponent, and you have to differentiate the power. Okay, for differentiation process, power we multiply in front here, but for integration process, okay, we integrate the power but we put it at the denominator, so you will have 2 here. Okay, so therefore this one is equals to negative 1 over 4 exponent 2x. Okay, so now this is your v and this is your u. So can you find your yp? Yes, you may do so since you already have your u and v, and you also have your y1 and y2 here. Okay, so therefore your yp is equals to uy1 plus vy2, which is equals to, so your u is equals to 1 over 2x, your y1 is equals to exponent negative 2x, plus v, your v is equals to negative 1 over 4, so negative 1 over 4 exponent 2x times your y2 is equals to exponent negative 4x. Okay, so just substitute your u, your y1, your v, and your y2. Okay, so you will have this one. So simplify this function since you have exponent and times by exponent. So therefore you will have 1 over 2x e negative 2x minus 1 over 4. So times, so a plus b, so you will have exponent negative 2x. So can you add this 2? No, you can't. Why? Because this one you have x here. Okay, so therefore this is your yp. So the last one, write your general solution as y is equals to yh plus yp. So therefore your yh is equals to, so just take this one, the whole thing as your yh. So you will have e negative 2x plus be negative 4x, and your yp is equals to the one that you just get in the previous step, which is this one, plus 1 over 2 x e negative 2x minus 1 over 4 exponent negative 2x. So this is your general solution. If you are given any initial condition, apply for you to get the value of E and B. The same process as what you did in UC. Okay, so this is basically how BOP solve non-homogeneous equation. Okay, so to confirm your answer here, okay, you try to solve this one by using UC case 2. Okay, why? Since your fx is an exponential function, right? So you can use UC case 2. So try to solve by using UC case 2. You should end up with this answer. Okay, so see you in my next video on next example. Thank you.